Hello friends, MoNaCo here with a first, trying to record my image as well as my presentation at the same time, so pardon me if there's any hiccups or bumps along the way. We're in our sixth video in our bonding homework unit. We're talking about writing and naming covalent compounds today, which kind of follows suits in what we've done in the previous naming ionic compounds, except there's a slight differentiation to the rules that we're going to apply. So you're going to be able to name covalent compounds given the formulas and give the formulas given the covalent name after our lesson today. At least have an idea how to start about doing it. There's a lot of practice for us to try this stuff because practice makes permanent, and you never practice until you get it right. You practice until you cannot get it wrong. That is the secret to succeeding in chemistry, if you ask my opinion. So what's so special about writing and naming covalent compounds? Well, it's just like writing and naming ionic compounds. Covalent compounds need to be universally named so that somebody in a different country knows what chemical they might be making in their factory or shipping across their borders or, consuming in their bodies. So the names have to be kind of universal. Down here in the examples, we have some compounds, formulas, and names that start to make a hint at the way that we're going to do this stuff. Okay, so for this one, we have a boron, and then the Br3. Well, we can see the bromide connection, but what about this tri? Tri has something to do with the number of them that we're going to be talking about. So the names and the formulas are related, and that's what we're going to be learning about. Okay, so let's check out some of the review notes. Okay, so recall that a covalent compound is most simply identified by a nonmetal bonding with a nonmetal, by sharing electrons. Okay, now a binary compound is one that has two elements bonded together. We get the term binary from the number bi 2. Ones and zeros are what computers talk in. They talk in binary code. There's two numbers in their language, 1 and 0, so binary. Ternary compounds are elements that have 3 or more elements bonded together. Okay, so more elements, bigger compound name. Simple enough. The procedure for naming compounds is very similar to the procedure for ionic compounds. The only difference is that you have to use these Latin prefixes. And no, there's no reference table for the Latin prefixes, so you've just got to know them. Mono, di, tri, tetra, hepta, hexnone, oct. See? I don't even know them all. I got a review, so let's check them out. Number of atoms in our subscript tells us what the prefix in front of the word is going to be. So mono, di, tri, tetra, I got that right. Penta, I think I got that one right. Hexa, I remember saying that, but this is where I always mess up. Septa or hepta, I guess they're kind of similar. Octo, nona, and deca. I remember deca, but I had to review. So one exception is that you always drop the mono prefix if there's only one atom of the first element in the compound name. For example, carbon monoxide. Once you draw this carbon monoxide, CO. We don't say monocarbon monoxide because there's only one element in the first part, in the first stop. There's only one of them. So we don't say monocarbon. That'd be kind of redundant. So, rules for writing chemical formulas. First comes the least electronegative element out in front of our formula. Second, the most electronegative element is written last. Now, the subscripts can tell you the prefix of each element in the formula. For example, CO2 is carbon dioxide. The 2 corresponds to the di because of our prefixes. Okay? So we're going to be practicing this over and over and over and over again. You might not be familiar with the rules as you go, but it's going to start to fall into place as we go. Now let's look at the first chemical formula, CO. Well, you would say carbon, because we always say the name of the first element out loud. And then the next element is going to be mono for monoxide. Carbon monoxide. So it's like the ionic naming rules, except that we have to apply the prefix. And the IDE is still there too. So let's look at this next one. Carbon, C, so we'll write carbon. And then there's 2 oxygens, so we'd have to put the prefix dioxide. Okay. Pretty common ones that we get into. I'm going to skip forward a little bit into a situation where we have 2 prefixes to apply. This one, N2O5. Well, there's 2 nitrogens, so I'd say dinitrogen. And then there's 5 oxygens, so pent. Dinitrogen, pent is my prefix, and oxide. Okay, so I'm applying all the prefix and suffix rules at the same time with covalent compounds. CCl4, well, there's carbon. So what's my prefix for 4? Tetrachloride. Now, if you're not getting this quite yet, at least you have the foundational knowledge to carry on a little bit here. So the formulas work backwards, okay? So we're given a name and we got to step back. So this is a little bit easier in my personal opinion, but maybe you don't find that the case. That's why we have so much practice to do. Nitrogen monoxide. Nitrogen, there's no prefix, so that must mean there's one of them. N, monoxide. Mon means 1, so 1 oxygen. NO. Oh, that's not so bad. Carbon tetrafluoride. Carbon does not have a prefix, so it must be a C. Now tetra. Tetra means 4, so there's 4 fluorides. So I'm going to put an F, and I'm putting my 4 down in my subscript. There's your formula. Let's try one down here. Dinitrogen pentasulfide. Let's do that one here. Dinitrogen means there must be 2 nitrogens. We don't put the 2's out front in chemistry, we put them down in subscripts. Penta means 5, and sulfide is S, so I'm going to try that way. So dinitrogen pentasulfide. Kind of cool. So let's see what we got left to do here. Oh, wow. We should be able to have at least a basic understanding of how to write and name covalent compounds using the IUPAC system. So remember to use your Latin prefixes and your suffixes. Okay, so it combines ionic, but the next layer is we put a prefix for the counting of the covalent atoms in there. Relevant practice, look at that, 8 pages of practice. So there we have it. Hope you enjoyed, and I'll see you in class.